Hello everyone, my name is Konstantin. Today I want to show you a local knowledge retrieval system I built for my second brain during the last week. The goal is simple. Take markdown notes, make them searchable by words and by meaning, and keep them retrieval local. In 6 minutes, I will show the utility, the index flow, and a quick search demo. You may You might ask, why build another? Local search utility tools such as QMD and other travel utility already exist. They are useful, and I wanted to build a rack system, and I need a OKF-oriented indexing. Index which not only stores some chunks of text, but also keeps the metadata useful during retrieval. In the future, I could use for scoping and for filtering and so on. In addition to OKF support, Second Brain CLI supports spell correction during indexing and retrieval. It's a small step can provide additional benefits. So let us break down the pipelines uh, to understand what happened during the indexing. The CLI find markdown files or read the YAML font matter and clean the notes content. It removes markup that doesn't help retrieval and applies spell correction uh, to the searchable text. Next, it's split the text into chunks and store them in SQLite database. The embedded models create vectors for those chunks. The result is on local database with two ways to find information. BM25 full text search when we know the words, and vector search when we know the idea but not the exact wording. Uh, SQLite is a small local database. There is no separate vector database, no Redis, and no Docker. It's a small local tool with a small local full footprint. Now let's uh, measure the logs for the index command with verbose login enabled. I use verbose mode because it makes the process visible. We can see which stages is running and how long it takes. Uh, Here the utility discover the nodes, prepare the content, store the chunks, and generate embedding. Embedding generation took us about 2 minutes. Uh, Let us search now. First, I will use keyword search. Uh, it's fast. Now let's use semantic search. It takes a little longer, but it retrieves related content even when my query use different wording. Let us compare the results. Keyword search is excellent when I remember the language from the node. Semantic search is for other moment. I remember the idea, but the note use completely different words. Both searches use the same local index, so I can choose the right tool, vector search or keyword search uh, instead of guessing. So what does it give us? Uh, when exact term, when I know exact term, I can use keyword search, mean-based retrieval when we do not, and spell correction, spell corrected content uh, underneath of both searches. Let's return back to our architecture to recap the practical advantages of that system. So the system is local, no cloud service, no API key, and no external infrastructure required for retrieval. SQLite keeps deployment lightweight, BM25, and vector search cover both known terms and for their content. Okay, for intent-oriented indexing, uh, preserve the structure of the knowledge base, and spell correction makes it better. The utility is written in Rust, so it's uh, delivered as a local binary and with benefit from Rust like memory safety guarantees. It can also expose the same search capabilities through MCP when an AI integration is useful. That's about wraps it up. I will add the GitHub repository links in the description. If you would like me to elaborate on the index on the search mode, please ask in the uh, comment section. I will answer each question. Thank you for your time.